All right, we're going to talk now about how to factor polynomials to find the rational roots. So first, let's recall rational numbers are real numbers that can be written as a fraction. Which means that they are either ending or repeating decimals. We talked about that back in Unit 2. So we are going to focus on the rational roots, and recall, we already know roots. Those are your zeros, x-intercepts, or solutions. So we've talked about roots with your quadratics, and now we're going to talk about roots with other polynomial functions. And we're going to recall the zero product property we talked about with quadratics, which said if you had a times b equaling 0, if you have a times b equals 0, then either a equals 0 or b equals 0. So we could use our zero product property when we factor to then set each factor equal to 0 and then solve each factor for your variable. So let's start with just using the zero product property. Now, in all of these problems, every single problem, I only want the rational answers. I do not want any imaginary answers or any irrational answers, only rational, which means I don't need you to find all of the roots. I need you to find all of the rational roots. Okay, so before we get to this, I'm going to add in this extra part. Because I only want the rational answers, you're going to solve all linear factors and then binomial, quadratic, factors that have subtraction and can be square rooted. We'll look at examples of what that means, but if it's a linear, you're definitely, if that factor is linear, you're going to set equal to 0, you're going to solve. If it's a quadratic, it must be a binomial, which you talked about in the previous lesson. Binomial is 2 terms. Quadratic means the exponent is 2. So something like x squared minus 16. You're going to solve a quadratic if it's a binomial. It has to have subtraction, and you have to be able to square root your number. So let's talk about why. When you're solving a quadratic, you are eventually going to take the square root, right? Because to get rid of a square is square rooting. So if you have subtraction, you're going to move it to the other side with addition. Make your number positive. You'd have x squared equals positive 16. But if you had addition, you'd have x squared equals negative 16. And when you square root a negative 16, that is not a real number. So I don't want that answer. And it has to be able to be square rooted, because if you have a number like 3, if you have x squared equals 3, when you square root 3, that is not a rational answer, right? So you do have to keep in mind that the number that we're talking about being square rooted, if it's just x squared minus a number, just focus on, can that number be square rooted? But if you had something like 2x squared minus whatever, then you're going to have to do a little work first to be able to decide if it can be square rooted. All right, so we'll look at some examples. You can see how all of this works. But number 1 is you're going to factor if it needs to factor. These 3 examples here are already factored. You're going to take each factor, set it equal to 0. However, I only need the linears or binomial quadratics that have subtraction and can be square rooted. So your first example here, which I know is kind of small on your paper, feel free to rewrite this where you can see this. This first one here, I have 3 factors, 1, 2, 3, each parenthesis. All of them are linear. So I'm going to set each of them equal to 0 and solve all three. So x plus 3 equals 0, 2x minus 5 equals 0, and x minus 7 equals 0. Well, if x plus 3 equals 0, then that means x equals negative 3, right? You would subtract 3 from both sides, x equals negative 3. On that second one, you would add 5 and then divide by 2. So that's going to give you positive 5 divided by 2. You flip the constant, so it was minus, it becomes positive, and then you divide by your coefficient. So it would become a positive 5 divided by 2. And the last one is x minus 7 equals 0, then x equals positive 7. Those are all of the rational roots. All of those are rational numbers. So my answer would be x equals negative 3, 5 over 2, and 7. Example number 2 is missing an equals 0, so you should get that added to it. I have two factors, x minus 2 and x squared plus 2x plus 4. The first one is linear, so I'm going to take that, set that equal to 0. However, the second one is quadratic, and it's a trinomial. So I'm not going to set that one equal to 0. If you did, you couldn't just solve by adding and subtracting. You'd have to use the quadratic formula, because it's quadratic. And if you did, you would end up getting either an imaginary number or an irrational number, which I don't want. So I only have one rational root. X minus 2 equals 0 means that x equals 2. You could set the other one equal to 0, use your quadratic formula, and solve, and notice that it's not rational, or you can just trust me when I say, if it's a quadratic, it's got to be a binomial. In this lesson, that's what we're doing. Okay, last one has two factors, x squared plus 4 and x plus 3. X plus 3 is linear. Definitely going to set that one equal to 0. But the other one is quadratic, okay? It's a binomial, good, but it's addition. So I'm not going to set that one equal to 0. You could, x squared plus 4 set equal to 0. You would subtract 4 from both sides, gives you x squared equals negative 4. And then you're going to take the square root and get a non-rational number because the square root of negative 4 has an I, which is not real. I don't want that answer. I only want the rational answers. So if x plus 3 equals 0, then x equals negative 3. Is the only rational root to that equation. So now we're going to talk about factoring it to then find your roots. So just a reminder that there are 5 types of factoring that you have learned. The first one is factoring your GCF. If you have a GCF, I highly recommend that you factor with the GCF first. Then you have factoring trinomials, which we'll remember how to do that. Then you have factoring sum or difference of cubes, factoring a difference of squares, or factor by grouping. Start with GCF always. A trinomial could possibly be factored using your trinomial. Sum or difference of cubes and difference of squares are going to be binomial expressions that we might be able to factor. And grouping are 4-termed expressions, okay? So, unlike in quadratics when we factored, and I said, you're going to have to factor one thing. That's not true of polynomials. Polynomials might have a GCF and then a trinomial and then a difference of squares. It might have a GCF, a grouping, a difference of squares, and another difference of squares. Got to do them all. So in your first example, 3n cubed plus 6n equals 0, you're going to start by looking for GCF, always. The GCF of 3 and 6 is 3, and the GCF of n cubed and n is n. So your GCF goes out front. You are going to divide both terms by 3n. 3 divided by 3 is 1. N cubed divided by n is n squared. Plus 6 divided by 3 is 2. And n divided by n is nothing. Inside your parentheses, you're then going to check that for any of the other types. So not a GCF, I've already done that. It's not a trinomial, so nope. It's not a difference or sum of cubes. It's not a difference of squares. And it can't be factored by grouping because there's not 4 terms. So that is factored completely. Now you look at your factors and decide which one or ones you should solve for. 3n is linear. So I'm going to solve 3n equals 0. Which means n equals 0, right? Because 3 times 0 is 0. My other one is quadratic. It is a binomial, but I have addition, so I don't need to do the other one. There's your solution. The only rational root to that function is 0. That does not mean that's the only root. It means it's the only rational root. Okay, example number 2, 5x squared plus 14x plus 8. So first things first is GCF. 5, 14, 8, nope. X squared, x, nothing, nope. Okay, next, it's a trinomial, so let's try and factor that. This is where you start by multiplying your first and last number. 5 times 8 is 40. You need 2 numbers that multiply to be 40 and add to be 14. What 2 numbers would do that? 4 and 10. If you recall how to factor this, you're going to take x plus, one of our numbers was 4, and x plus the other number was 10. I'm not done factoring. You do not set this equal to 0. You are not done factoring. Got to deal with that 5 in front of your x squared. You are going to divide both 4 and 10 by 5. Four over 5 does not divide. It does not reduce. So you slide the 5 in front of x. But 10 divided by 5 is 2. Now I'm going to double check that those binomials are not sum or difference of cubes, and they are not a difference of squares. So I'm done factoring. Now I can solve. Since both of them are linear, I will set both of them equal to 0. In that first one, since I have plus 4, it's going to become x equals negative 4, and then divide it by your coefficient, so negative 4 over 5. And your second one will become a negative 2. There are your rational roots to your second example. Next example. First, when you have an equation and it's set equal to y, well, I want to find the x-intercepts, so all I do is replace that y with a 0. Now continue like you did before. Check for GCF. 5, 3, 5, 3. Nope. X to the fourth, x to the third, x squared, and x. Yes. They all have an x in common. So you take out an x, and then that's going to give you 5x to the third minus 3x squared minus 5x plus 3 equals 0. We have factored, but we have not factored completely. We need to continue. Inside your parentheses, that is a 4-term polynomial. So we are going to try to factor by grouping. Factor by grouping is you split your polynomial in half. I'm going to find the GCF of the first 2 terms. 5x to the third minus 3x squared has an x squared in common. So your initial GCF comes down here. Big bracket. Your GCF of your first 2 terms is x squared. That leaves you with 5x minus 3. Now you need to figure out the GCF of the next 2. And 5x plus 3 has nothing in common. So it's 1. Now you need to decide if it's positive or negative. When you factor by grouping, what you have inside your parentheses here has to match what's in your other parentheses. So it needs to be a positive 5 and a negative 3. But it's a negative 5 and a positive 3. So I need to take out a negative 1. Your parentheses have to match. If they match except for your signs, then take out a negative. If you took out a negative and the signs don't match, fix it. Don't take out a negative, take out a positive. So now let's finish factoring this, because x, your first parenthesis is what they have in common, 5x minus 3. Your second parenthesis is your GCS you had, x squared minus 1. Did the order of your parentheses matter? Absolutely not. You could have put x squared minus 1 first and then 5x minus 3. Now, I will tell you, you're not officially done factoring. Your x squared minus 1 can factor some more, but I'm also going to show you how from here, with a difference of squares, because this is quadratic, you can stop. If it was cubic, you cannot stop. You have to continue. But with it being quadratic, we can be done. So now let's solve. I have a linear term, a linear factor, and a quadratic factor. So the first two linears, definitely set those equal to 0. Now let's decide if we should set the quadratic equal to 0. It's quadratic, so it's binomial. Yes. It is subtraction. Yes. Can 1 be square rooted? Yes. So I set that equal to 0. X squared minus 1 equals 0. X equals 0. So x equals 0. The next one, I'm going to switch the sign of the constant and then divide by my coefficient. So it becomes a positive 3 divided by 5. Now your last one, if you have x squared minus 1 equals 0, then that means x squared equals 1. You're in a square root. Now here's where you need to remember that when you square root, you get two answers, because you get the positive and the negative. So you get plus or minus, the square root of 1 is 1. So your solutions are x equals 0, plus or minus 1, and 3 over 5. You also could write it as 0, negative 1, 1, 3 over 5. I don't care your preference, as long as you have all four. 0, plus or minus 1, and 3 over 5, or 0, negative 1, positive 1, 3 over 5. Those are all of the rational roots to that function. Okay, looking at our first one, no GCF. It's not a trinomial. It is a sum of cubes. And I know that a lot of you are not going to remember how to factor sum of cubes, but here is the really cool thing about this lesson with this. Can you remember how to factor the first parenthesis for a sum or difference of cubes? Remember, there's supposed to be two parentheses. The first one is usually the easier one. It's take the cubed root of both of those numbers. Cubed root of x cubed is x. Keep the sign as positive. The cube root of 1 is 1. Your next parenthesis is going to be a quadratic trinomial. I don't want to factor that. I don't want to solve that. I don't care about it. If you can remember that first parenthesis and how to get it, that's all you need to solve a sum or difference of cubes. Now, I will remind you how to do the rest of that parenthesis, but you're not going to need it to find the rational roots. So, to find your next parenthesis, it's taking the first term, x, the first term here, and square it. Opposite sign, then take both of your terms inside that parenthesis and multiply. So x times 1 is 1x. And then take your last term in the parenthesis, 1, and square it, and it's always positive. If you forget how to get that set of parentheses, that's fine. I need the first parenthesis because that is the only one that gives you a rational root solution. So as long as you know how to get that x plus 1, the other one doesn't matter because it's not a quadratic binomial. So your only rational root comes from x plus 1 equals 0, which means x equals negative 1. F of t is just like 0. So you're going to replace the f of t with a big old 0. 4t minus 81 does not have any GCFs. It's not a trinomial. It is a difference of squares. You have to factor a difference of squares completely. Okay, you can't, like the last one, I only cared about this first parenthesis. Not true in a difference of squares. Only sum or difference of cubes. Difference of squares is still two sets of parentheses. Take the square root of both of your things. The square root of 4 is 2. Square root of t squared is t. Put a minus sign. Square root of 81 is 9. Second parenthesis is the exact same, except put a plus sign. 2t plus 9. Both of your factors are linear, so you're done factoring. Here, set them equal to 0. The first one, you're going to get positive 9 and divide it by 2. The second one, you're going to get a negative 9 and divide it by 2. There are my two answers, positive or negative 9/2. You may write it as two separate answers, or you may write it as one answer like that where you have your plus or minus sign. Up to you. Remember that y is 0. You have a trinomial, so multiply. 5 times 6 is 30. I did skip GCF, but that's because 5, 11, and 6, no GCF, and the last term doesn't have an x, so you get to skip that step. I need two numbers that multiply to be positive 30, but add to be negative 11. So I need two negatives, because two negatives multiply to be positive. Negative 5 and negative 6 will do that. So that gives you x squared minus 5, x squared minus 6. X squared because I had an x to the 4th. I split that in half, I get the square. And two minus signs because I said minus 5 and minus 6. Or my two numbers that multiply to be positive 30 and add to be negative 11. But then I'm not done factoring because I need to divide both of those by that 5. Five divided by 5 is 1, but 6 does not divide by 5, so put your 5 in front. 5x squared minus 6. I'm not going to be able to factor that one anymore. It's not going to be a rational root. Why? Because you have to take the square root. You cannot take the square root of 5 or 6. But the first one is a binomial. I have subtraction, and one can be square rooted. There you go. X equals plus or minus 1 because you took the square root. When you square root, you get two answers, positive and negative. Those are the only rational roots to that function. And your last one. There's a GCF of G. You then have a trinomial, so you're going to multiply 3 times 20 is 60. Two numbers that multiply to be a positive 60, but add up to be a negative 19 means I need two negatives. 4 and 15 will do that. Negative 4 and negative 15, which need to then be divided by 3, since that's your number in front of the G squared. 4 can't be divided by 3, so it gives you 3G minus 4. 15, however, becomes minus 5. I have three factors, and they are all linear, so G equals 0. 3g minus 4 equals 0, and g minus 5 equals 0. Obviously, g equals 0. That's done. Your second one, flip the sign, divide by your coefficient, so positive 4 over 3, and then positive 5. So your solutions that are rational roots are 0, 4 over 3, and 5.